Video, we want to look at the distance between points, and this will relate back to the changes between points that we had in the last video. So let's consider first of all the point 3, 4 right up here. So we'll call that point A in this video, 3, 4. So let's find the distance of this point from the origin, so from 0, 0. Well, to do that, we can, if we're thinking about this geometrically, it's fairly easy to see that we can draw a triangle like this. And this will in fact be a right triangle. And the sides of this triangle are 3 and 4. So hopefully you know the Pythagorean theorem, which says that if you have the sides of a right triangle, we can say that side A squared plus side B squared is equal to C squared, where C is always the longest side, also known as the hypotenuse of the triangle. So in this case, we could let A be 3, we could allow B to be 4, and we're trying to figure out what C needs to be. So let's simply plug in the numbers and figure out how large C is. So A was 3, so 3 squared, we'll write it out, plus B was 4, that's 4 squared, must equal whatever C is squared. So working this out, this would equal 9 plus 16, that's what C squared must be. So we have multiple equal signs, so we can get rid of those. Line up our equal signs. And therefore 25 must be C squared. Well, this one works out very nicely. If 25 is C squared, the length of C must be 5. So if we went over 3 units to the right and 4 units up, the diagonal between the origin and A has a length of 5. Let's consider some other points. Let's go back to point A, which is at 3, 4. And consider point B, which we'll put at 3, negative 4. So we hadn't considered points in the last video that were vertically aligned or horizontally aligned. If I want to find the distance between these, 3, 4, and 3, negative 4, we don't need to use a Pythagorean theorem. We can just look at the distance of the line connecting them. To get from an x value of 3 to an x value of 3, there's no change in the x direction, so delta x is 0. But delta y, we went from 4 to negative 4, so y changed by 8 units downward, so we would call that negative 8. But we would say that the distance between the points is the absolute value of that, so the distance would just be 8 between those points. But let's go back to using the Pythagorean theorem. So let's consider point A again, which is at 3, 4. And let's put point C up here now, which will be at 5, 1. And we want to find the distance there. This relates directly to what we did in the last video. It would be very helpful to draw in a triangle that drops down like this and goes over like that. How far did it drop? It went from 4 down to 1, so it dropped a delta y of negative 3. And it went over in the x direction by a delta x of positive 2. So if I draw in the distance between these, the line segment that represents the distance between the points, it is the hypotenuse of a triangle that has one side of length 3 and another side of length 2. So let's fill in the Pythagorean theorem to find out how far apart the points are. If you want, you can use negative 3 for the A side. When you square it, it will still be 9. So it doesn't really matter if you call it 3 or negative 3 in length. Its length would be 3, but you could say that delta y is negative 3, and delta x is going to be 2. We'll let that be the b value and square it, so those have to add up to c squared. So what happens here is we get 9 plus 4 is equal to c squared, and this time 13 is equal to c squared. Clearly this one doesn't have a nice answer. 13 is not a perfect square. So what we have to say is that c is the square root of 13. Since 13 is between 3 squared and 4 squared, we know that our value for c is somewhere between 3 and 4, which should make sense because if the y change is 3, the hypotenuse is clearly larger than the change in y. And so if you look at its size, by comparison, if you go from A to B and consider the length of that line segment, it's definitely bigger than 3, but it wouldn't quite be 4 units long. So we would say that the distance is the square root of 13. If you wanted to, you could convert that to a decimal, but you would never get exactly the right answer. You would have to round that at some point. So the actual distance between those 2 points is the square root of 13. So what we can see in this video is by drawing triangles and relating the delta x and the delta y that we had calculated in the previous video, we can use those values as the sides of a right triangle, the shorter sides, and then using the Pythagorean theorem, we can find the length of the diagonal.